Continuing along here, we have been talking a lot about vertical shifting and horizontal shifting. Now we're going to move on to some other kinds of transformations of functions. We're down here at the very bottom of the first page of the handout. We have to do example 5. We're going to compare two functions again. One is our old friend, the absolute value function, and the other is just a slight variation on absolute value. And I have, it's g, it's the minus of the absolute value function. And let's just compute some values. I'm going to use the same values of x that I used in my table for x. So let's move these up. And now I'm doing minus the absolute value of -3. So this is a case where the two minus signs do not cancel out. You have to do the absolute value first. And when you do the absolute value inside, you actually get a +3. And then you take the minus outside, you end up with a -3. So you got to convince yourself that this ends up being -3. This is not a case where minus a minus is plus, because basically the minus sign outside the absolute value and the minus sign inside do not communicate with each other, do not affect each other. The minus sign outside has to wait until the absolute value has been performed, and then the inside minus sign is gone. So the outside is still there. We end up with -2. Minus the absolute value of -1 is minus a +1 or -1. Minus the absolute value of 0 is just going to be 0. Now minus the absolute value of 1 will be -1. These I won't have to convince you so much. -2, and minus the absolute value of 3 is going to be -3. So notice all these y values are negative or 0. We have no positive y values. Let's go ahead and plot these points up on our graph grid where we already have the function f. So I have -3, -3, -2, -2, -1, -1. I have 0, 0. I have 1, -1, 2, -2, 3, -3. So I'm getting a point, but it's an overturned V-shaped point, right? So the graph of G, again, is sitting below the x-axis. And so what's the relationship here between the two graphs? Well, there's what we call a reflection going on here. We say we reflect the graph of f through the x-axis to get the graph of G. So this is a reflection through the x-axis. And so it's not a vertical shift, it's not a horizontal shift. It is like you take a point on F. The way to think of the reflection is you go straight to the x-axis, and then you continue the same distance you already traveled. So if you go down 3 units to get to the x-axis, you continue on for 3 units. If you just go down 1 unit to get to the x-axis, you continue 1 unit in the opposite direction. Or another way to think of it is I could just fold, say the ink was wet, my blue ink was wet. If I folded on the x-axis and pressed down, I would get an impression of the graph of G down below. Okay, so this is a new kind of transformation, a reflection through the x-axis. And we want to think about how the formula for G is telling us how we're going to recognize that without having to plot a lot of points. Now I think we're ready to go to the second page, finally, of our handout. So we're going to do example 6. And example 6 is, now this is going to be kind of different, all right? We've been seeing these in pairs, so there's some similarity here between 5 and 6, but also something different. And I'm working with a new function now. I guess we haven't graphed this one yet today, so I'm going to write it out, square root. But we have done it before, so we all know. Square root of 0 is 0, square root of 1 is 1, square root of 2, we can use a decimal, it's about 1.4. Square root of 3 is about 1.7, right? Square root of 4 is exactly 2. And then just note, we've already talked about this, if we try to plug in a negative, we can't do it. We can't get real numbers. So for negative values of x, the function is not defined. There are no points to plot. All right, so let's just go ahead and sketch our graph. We've been doing that with each one of these. Let's sketch the graph of f first. So I have my axes set up for x and y here. 0, 0, 1, 1, 2, 1.4, 3, 1.7, 4, 2. And maybe I'm going to add a point on here. If I go all the way out to 9, square root of 9 is 3. That allows me to add an easy point on the graph. 9, 3. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 3. That just gives me something to aim at here when I go around this curve. There we go. So there's a graph of f. It only exists to the right of the y-axis, right? There's no portion of the graph to the left of the y-axis. There's no portion of that graph below the x-axis. That's the square root function. Okay, now let's do some calculations with our g function. With 0, if I take the square root of minus 0, that's the square root of 0, which is 0. So we got 0, 0 on our graph. If I want to plug in 1, I got to take the square root of negative 1, or 2, square root of negative 2, 3, square root of negative 3, 4, square root of negative 4. Okay, stop, stop, stop. So this function is not defined when I try to plug in positive values of x, because I end up trying to take square root of a negative. And so if we had to vote on it, you'd probably say, let's just forbid this expression from being in the land of functions. It's so weird looking, but it turns out it does have meaning. In fact, let's just think about what would happen if we tried to plug in a negative 1 for x. We'd get the square root of minus sign from the function expression, a negative 1. We actually end up with square root of positive 1, which is 1. So we do get a point on the graph. If we plug in negative 2, we get the square root of minus a negative 2, square root of 2, which is about 1.4. So what you can do with this funny function g is you can plug in negative numbers. Negative 4 is going to be the square root of minus a minus 4, which is square root of 4, which is 2. And guess what we're going to get at negative 9? I bet you can realize we're going to get positive 3 out of that. So let's go ahead and plot points that we have for g. Now we have no points to plot when x is positive, but we do have 0, 0. That was our very first point. And we do have negative 1, 1. And we have negative 2, 1.4. Negative 3, 1.7. This is negative 4 here. Negative 4, 2. And 5, 6, 7, 8. Here's negative 9. Negative 9, 3 is what I need to be able to draw this. And I think you can see what's going on here now. There is a similarity in shape of the two graphs. This is a graph of g, what we have to do here is, I think you can see, we have to reflect the graph of f through the y-axis to get the graph of g. So this is also reflection, like the previous example, but this is a y-axis reflection, not an x-axis reflection. So we want to think about the difference between these two. Here, the minus sign that we introduced was inside the function. In example 5, the minus sign that we introduced was outside the function expression. And that's going to make all the difference in the world. And in fact, on our handout, we have our general statements here. We can reflect the graph y equals f of x about the x-axis reflection to obtain the graph of y equals minus f of x. Notice the minus sign is outside. We can reflect the graph of y equals f of x around the y-axis to obtain the graph of y equals f of minus x. Notice that minus sign is on the inside. So that's the difference between this x-axis and y-axis reflection. You got to memorize that difference. And we're going to go ahead and do example 2 in the next video segment.